Hi, my name is Canovan. I'm a researcher at the University of Central Lancashire in the UK. I'd like to tell you a bit about a project I've been working on with my colleague Naomi Fallon about the impacts of COVID-related school closures on primary science teaching and learning. So Naomi, maybe you could introduce yourself and the project?
Hello, my name's Naomi Fallon and I'm a research assistant at the University of Central Lancashire and a PhD student at the University of Greenwich. I'd just like to tell you a little bit more about what motivated this study and how we conducted it. A bit of background. Although there is constant discussion in the UK about how to tackle labour shortages in science and technology, there is also a long-standing concern about teaching of the subject at primary level, especially as government testing policies encourage schools to prioritise maths and English. For this reason, among others, we were concerned that the sudden COVID-related school closures would have a more severe negative impact on science teaching and learning than on other subjects. We therefore decided to study what actually happened during the closures using contemporaneous investigations. The first closure period lasted from March 2020 until June for some children and September for others. During April and May, when around 95% of children were participating in home learning, we conducted online surveys with around 180 primary school teachers and 360 parents of primary-aged children. The UK government announced a second closure period in January 2021 at very short notice. This lasted until March, and during that time we went back to 100 of our previous participants to find out how the situation compared to that of the previous year. Our study is ongoing, and we will continue to track the medium to long-term impacts of the closures on primary science over the coming year.
Thank you, Naomi. Okay, so I'm just going to briefly run through some of our key findings. So the first thing was that, as we had feared, we did find that during the first round of school closures, less science was taught than usual. And as you can see from the data in the PowerPoint, significant proportions of teachers said that work set was mainly maths and English, that pupils were given science tasks less than once a week or not at all, that pupils were given less science in general. And again, as we had expected, maths and English did take precedence. Almost all parents said their children had participated in school-provided maths and English, but only about 6 in 10 said the children had engaged with school science. In closure period 2, we did find that home learning in general was better. And because home learning in general was better, science was somewhat improved as well. However, it did continue to lag behind. So parents reported poor quantity of science provision, poor quality, being sent links to TV programmes, for example, lack of practical activity, and there were still quite a few saying that no science teaching had happened at all during either closure. But there is another very important facet to our findings, and that is that children in more deprived areas were more severely affected by this cut to school science. So we talked to teachers who worked in deprived areas of the country, and they reported finding it significantly challenging to teach science remotely, much more so than their counterparts in affluent areas. So 2/3 of this group working in deprived areas said it was difficult to translate the science curriculum for home learning. And they also said were much more likely to say their pupils were doing less science than usual. And they cited various issues such as availability of resources within the household for simple experiments, access to the internet, and also concerns about parental ability to support science learning. So we can say that primary science did, as we had feared, suffered disproportionately during school closures, and pupils in more deprived areas were found to be more severely affected by this. But another crucial point is that efforts to reverse this effect cannot be left until children reach secondary school. So we have research showing that in the UK, young people's attitudes to science are largely set by age of 10 or the end of primary school. Now, we're seeing a strong tendency among policymakers and school leaders to prioritise literacy and numeracy catch-up in this age group. But assuming that children can come back to science later risks missing a crucial window to inspire them with science and make them feel that it can be part of their future. So as a takeaway, I'd like to leave you with this quote from one of the papers we published on this research. We know that science attitudes and motivations are set at a young age, and so the gap that looks likely to have been widened by the effect of the closures must be addressed swiftly in order to reverse negative impact on efforts to widen participation in science. Thanks very much for listening.